this video, we'll be looking at the topic of potential dividers. Now, potential dividers are actually a very simple concept. If you have a series circuit and you have two resistors in series, then you have a potential divider. Now, generally this can take a variety of different forms, perhaps one of those resistors in parallel with something else. Or maybe one of the resistors is a specialist resistor, like a thermistor or an LDR. In either case, we know that the potential of the supply is shared across everything in series. So if we consider two resistors, R1 and R2, in series, we know that VIR will apply and that the current going through both will be the same, because the current is constant everywhere in a series circuit. So we can say V1 equals IR1 and V2 equals IR2. So we can form a ratio with these. So if we simply divide one by the other, so in this case, let's just say divide V1 by V2, we can end up with a very simple ratio that shows us that V1 over V2 is equal to R1 over R2. Because the current being constant means it cancels out. So this can allow us to use very basic ratio patterns as we've seen before. But it can also be used to form an equation for this that is not given, and some people prefer to use a single equation rather than multiple steps with VIR. So, in forming this equation, we are basically going to take what we have seen above, except taking one of those sources, one of those resistors, as being the whole circuit. So we're saying V1 over V total. So the ratio in that respect will be R1 over R1 plus R2. So this is following the idea where the resistance of a single resistor is obviously its own value, but the resistance of the circuit in series is R1 plus R2 plus etc., whatever number you have in series. So if we simply rearrange this, we end up with the equation that is recommended for potential dividers, which is V1 equals R1 over R1 plus R2, all bracketed and multiplied by the total potential difference, V. So some people will strongly recommend memorizing this equation and utilizing it in every potential difference calculation. I personally am not a massive fan and would rather use VIR, but it shows there are multiple ways to approach these questions. So let's try this one. We have a very simple circuit here, two resistors in series with a cell. We know that we have a potential difference of 12 volts across our supply, which means there will be 12 volts transferred in total across both of these resistors. We also know the values for the resistors, where one of them is 100 ohm and the other is 200 ohms. It doesn't matter which is which, neither are specifically labeled, so let's just write them down as so. And we've got a voltmeter across each of these, labeled V1 and V2, simply for ease of labeling and easily identifying during calculation. So let's use the equation we just formed. So V1, to find the potential difference of the first resistor, is R1 over R1 plus R2, all multiplied by the total potential difference. Now this is actually quite easy to do with this one. So we have 100 for R1, 100 plus 200, all bracketed and multiplied by 12 for the supply voltage. Quite quickly, you should be able to notice that this is 100 over 300, which can very simply be brought down to 1/3, multiplied by 12. So to find a third of 12, well, divide by 3 and we get a total of 4 volts. Now we could plug everything in again for V2, but we don't need to. We know that every resistor or every component in series with the supply will receive the sum of 12 volts. So if we take this 4 volts away from the 12 volts, we end up with 8 volts. Now, as straightforward as this seems, there are many easier ways, because what we can notice is that if R is equal to V over I, then R is proportional to V. Therefore, if we increase the resistance, the potential difference increases, and vice versa. So looking at these resistances, 1 to 200, we have a 1 to 2 ratio. So knowing we have 12 volts to begin with, we can easily determine that it will be a 4/8 split. Now, not every version of a potential divider question will be this easy. Very often you'll have a variable resistor or something like that in one of these situations, requiring multiple different steps. Thank you for your time.